Hello friends, this is Urvi Singhavada from SSIT Part Gandhinagar. In chapter number 1, we already discussed the DC circuits. Now today we'll discuss the chapter number 2, AC circuits. Now before we start the AC circuit, we should aware with the terms related to the AC circuits, and then after we can define the AC circuits in detail. Now in AC circuits there are so many important terms that we should aware with before we learn the AC circuits. So the first term, the terms which are related with the AC circuits, the first term is waveform. Now in this first definition you can see the shapes of the waveform, different types of waveforms. Why this waves are called AC waveforms? Because we'll get this waveform in both the side, means positive side as well as the negative side from the reference. This line indicates this is the reference line. From reference line you can see from above side and from the below side you will get both the side signals. So these waves are called AC signals. Now waveforms defines this is the we can say it is defined as the graph between magnitude of alternating quantity. So this axis is indicate y-axis and this is the x-axis. In x-axis you can see the time, and at y-axis you can see the amplitude of the signal. Now there are so many shapes of the waveform. The first waveform indicates this is the sinusoidal waveform. Now second is the square wave. Now you can see from 0 to pi and pi to 2 pi. And the third waveform is of the triangular wave. You can see the shape of the wave is in triangle. Now any of the shapes, this is the complex wave, the magnitude and the we can say time period, the variation of the wave is not proper, but this is also called a waveform. So this is the definition of waveform. You can check the magnitude and amplitude of this signal with respect to x and y axis. Okay, now the second important term is cycle. Now cycle defines it is a set of positive and negative shape of the waveform. Means whenever a signal completes one positive wave and the negative waveform for particular time, means one complete set of the positive and negative is called the cycle. So from 0 it is starting from 0, and then again at 90 it is maximum, then 180 it is 0, then at 270 it is negative maximum, and 360 it is again a 0. Means this is called one cycle. Means it is defined as one complete set of positive and negative and 0 values of an alternating quantity. Now the next important term is instantaneous value. See, we are as we are discussing alternating quantity. Alternating quantities have only an instantaneous value. Means instantaneous value, this word defined as instant, means at every instant of time you will get the different amount of current. Means in previous slide as we see, this is an alternating quantity waveform. Now suppose you check at suppose this point. So at this point the magnitude is different, and at pi by 2 time it is different. So at every instant of time you will get a different value or different amount of voltage and current. So that's why it is called instantaneous value, and it is always indicated with the small letter. Small I is the instantaneous value of the current. Now small v is the instantaneous value of the voltage. If the waveform shown is of voltage waveform, then it is indicated by small v, and P indicates instantaneous value of the power. Now next term is amplitude. See, the synonyms of amplitudes are amplitude, peak value, crest value, and maximum value. All these names are same. So amplitude defined is it is defined as the maximum value, either positive or negative. Means in this way you can see at this point the signal is maximum at pi by 2, means it is positive side, but at this side means at 3 pi by 2 it is negative maximum. So in this it is defined as positive or negative maximum value attained by the alternating quantity in one cycle. Means whenever a signal completes one cycle, it reaches twice maximum, two times means maximum. First is positive maximum and second is negative maximum. Now if we have the current waveform IM, so current waveform I, then IM indicates the maximum value. If we have the EMF waveform, then EM indicates the maximum value of the EMF. Now PM indicates the maximum value of the power. Now next term is average value. It is defined as the average of the instantaneous value of the alternating quantities over a half cycle. Means you will get an average value. Means we have an alternating quantity, so at every instant of time the current, we can say if we draw a waveform of current, it is different from 0 to 360. So if we want to find an average value of that signal, we will take the average of each instant of time, means from 0 to 2 pi, we will get the average value of the signal. Now the next term is RMS value. RMS value defines RMS value. See, whenever we have DC circuit and AC circuit, so when we pass DC current through any element for a particular time interval, then whatever the heat generated by that DC current, now the same heat generated, so suppose we want to generate same heat and we pass that current, means it is the equivalent DC current with when flowing through a given circuit for a given time. Means if we have a DC circuit and we are giving DC supply to that circuit, and whatever amount of heat generated for that particular time and for that particular current, now same heat if you want to generate in AC circuit, then the value which is required to generate same heat for that particular instant of time is called the RMS value of that AC quantity, means alternating quantity. So if we check the RMS value of the voltage, then Vrms indicates the root mean square value of the voltage, and Irms indicates the root mean square value of the current. Now the next important term is frequency. As we all know that in India our frequency is 50 Hz. So frequency is a time taken by the signal to taken by the signal for 1 second, means to complete the cycle. So it is defined as the number of cycle, means in 50 Hz. Suppose we have the 50 Hz frequency. So if we write an equation over here, f is equal to just a minute, this is now if you write f is equal to 50 Hz, so our alternating quantity f is we can say it is defined as the number of cycles completed by an alternating quantity per second. The symbol is f in Hertz. Now the time period, now it is defined as the time taken to complete one cycle. The symbol is t and unit is in second. Now if you want to find a time regarding our signal is, then time period t is equal to 1 over f. The equation is 1 by f. So if you place f is equal to 50 over here, so it is 1 by 50, and your output is 0.02 second. So it means we can say that for in 1 second our signal complete in 0.02 second our signal will take time to complete one cycle. Now the next important term is power factor. It is defined as the cosine angle between voltage and current. If we plot a vector diagram for voltage and current, So there is an angle between voltage and current vectors that indicates the power factor of the system. Now power factor indicates with the cos phi, where phi is the angle between voltage and current. If we plot a voltage and current like this, suppose this is a voltage vector V and this is the current vector I. So this is an angle theta, indicates the power factor angle. Now active power, now it is actual power consumed by the circuit. Means suppose if we taken an example, at our house we have the AC. So AC having we have the different ratings, 1 tons, 1.5 tons. So that 1 tons and 1.5 tons indicates that the consumption of the power of that air conditioner. Now active power, you can see that it is the actual power consumed by the circuit, means the actual input power consumed by the circuit, and it is a product of voltage and current and a power factor angle cos phi. Now active power indicates with the P is the active power indication, capital P is equal to I square R, and for I square R we can write VI cos phi, and the unit of active power is in watt or kilowatt. If the power is large, it indicates that active power with the if our power is small, then it is in watt. If our power is large, then it is kilowatt. The next important term is reactive power. Now this power is we can say this power drawn by the type of circuits we have, or type of the appliances we have. The power drawn by the circuit due to reactive component means we have the inductive circuit in our we can say setup, then reactive power consumed by the circuit will be more, and if we have the capacitive circuit, the reactive power consumption by our circuit is small or negligible. So reactive power indicates the power drawn by the circuit due to reactive components. Reactive components basically are inductor and capacitor. Now the power drawn by the circuit due to reactive component of the current is called the reactive power. Now it is defined by, in the previous definition we have the angle between V and I was the cos phi. Now this is the sin phi. The sin phi indicates this is the reactive power, and reactive power indicated by the alphabet Q, capital Q. Now Q is product of I square and X. Now it is defined by VI sin phi. Unit of reactive power is VAR. If the reactive power is large, then it is indicated by kVAR. Now the third power is apparent power. Apparent power basically a resultant power of reactive power and active power. We have the system that may be inductive in nature or capacitive in nature, or we can say combination of inductor and capacitor. Then the resultant power consumed by that appliances or system is called the apparent power. It is product of RMS value, as we already discussed RMS value of the voltage and RMS value of the current. It is the total power supplied by the circuit. Now apparent power is indicated by S, and it is a product of voltage and current. There is no angle difference between V and I, because it is a resultant power, and the unit of apparent power is VA, and if the power is large, then it is in kVA. The next important term related to AC circuit is peak factor or crest factor. Peak factor define the peak to peak value of the signal. Now it is defined as the ratio of peak value. Peak value means what? Suppose we draw a waveform like this. This is our waveform, suppose. So this point indicates peak value, positive peak and negative peak value. So it is the product of it is defined as the ratio of peak value, means crest value or maximum value. These are the synonyms of the peak value to RMS value of the alternating quantity, and this this value is we can say important for the calculation of the example for AC circuits. Now peak factor is defined with the Kp, and the value of peak factor is 1.414 sine wave. Now the next term is form factor. Form factor form factor is again a ratio. Form factor again is a ratio. Just a minute. It is again a ratio. It is defined as the ratio of RMS value of the RMS value of the average value of an alternating quantity, and it is denoted by Kf. Just keep in mind the ratio value Kf. The previous one was Kp. Kf is 1.11 for the sine wave. This will also useful to calculate the example related to form factor. See, the next important term related to AC circuit is phase difference. Now you can see over here three different waveforms which are starting with different time interval. See, the first waveform is starting from 0. Now the another waveform is starting with some angle theta, means it is behind the reference, and and the next is starting above the reference. So this is called phase difference. Phase difference, here the Vt is defined as Vm sin omega t. There is a phase difference, means this wave is behind the reference, that's why it is omega t plus phi, and this reference is ahead to the this wave is ahead to the reference, so that's why it is omega t minus phi. This is called phase difference. This is defined as the angular displacement between two zero values or two maximum values of the two alternating quantity. See, leading phase difference and lagging phase difference, these are the types of phase difference. This wave indicates this is the lagging waveform, and this indicates this is the leading waveform. If you have any doubts and query related to this lecture or any this topic, please you can contact me, Purvish Mewada, Electrical Department. Thank you very much.